Back. This is Mr. Hassan's Maths channel, and I'm now going to be going through question number 9 from the January 2023 International A-Level Edexcel Pure Mathematics P2 paper, Edexcel board for the International A-Level. It says, in this question, you must show all stages of your working. Solutions based entirely on calculated technology are not acceptable. All right, so now here we have a figure which shows a curve C with the equation y equals x squared minus 4x plus 5, which is, of course, this quadratic, x squared minus 4x plus 5. And the line with the equation y equals 2, well, that must be this line here, this horizontal line. So that means it's passing through this point 2 on the y-axis. And the curve C intersects the y-axis at the point D. So that's where the y-intercept of this curve. So part A of the question says, write down the coordinates of D. Okay, so the coordinates of D are the place where this curve cuts the y-axis. Okay, now we know that the equation of the y-axis is x equals 0, because everywhere on the y-axis x equals 0, just as the x-axis equation is y equals 0, because everywhere on the x-axis y equals 0. So where it crosses the y-axis is going to be when x is 0, which means when y is 5. Okay, you can see that from the equation straight away, the constant is that place. But what's the reason behind it? The reason behind it is when you substitute 0 instead of x, you end up with the constant that's behind. So the coordinates of D are 0, 5. Okay, so it says write down. You don't really have to show any steps. It's just 0, 5. Simple as that. But if you want to show the steps, you say that it's when x equals 0. So you have y equals x squared minus 4x plus 5. So that means you have 0 squared minus 4 times 0 plus 5, which gives you 5. So when x is 0, y is 5, that's the point 0, 5. Okay, that's the reasoning behind it. Now, then it says the curve C intersects the line L and the points E and F as shown in figure 3. So it intersects with this line y equals 2, basically. Find the x-coordinate of E and the x-coordinate of F. Okay, so we got to find where the line or the curve y equals x squared minus 4x plus 5 intersects with y equals 2. Right, so basically we can replace this y with x squared minus 4x plus 5 and solve this equation. I'm going to find when that's equal to 2, basically. So this is a quadratic equation. Now, to solve this equation, what we're going to use is a zero product property. So we have to bring everything to one side. What you can't do is you can't like factorize this. Now, one of the things that some students try and do, although you can't even factorize it anyway, they will try and express this as 2 factors equals 2. And if they're able to factorize it, they will then say, oh, either this factor is 2 or that factor is 2. No, that's not correct, because when you are factorizing, when you're solving a quadratic equation by factorizing, you are using what's called the zero product property. All right, so you're using the fact that 2 things multiplied together give you 0, then one of those things must be 0. If 2 things multiplied together to give you 2, it doesn't necessarily mean one of them must be 2. You can't say either this is 2 or that is 2. No, that doesn't make sense. But if two quantities, A times B, gives you 0, one of them has to be 0. Either it's the A that's 0 or it's the B that's 0. So that's how we use the zero product property to solve quadratic equations. So what we've got to do here is we've got to make it say equals 0. So I'm going to subtract 2 from both sides. So I have x squared minus 4x plus 3 equals 0. We subtracted 2 from both sides. Okay, subtracted 2 from this side became 0. Subtracted 2 from this side became plus 3. Now, because we have it set to equal 0, we can now factorize this. And this is where they want to see the factorizing. This is one of the parts where they mention here, solutions based entirely on calculate technology are not acceptable. So if you were to just write down the answer, for example, x equals and x equals, because you just put it in your calculator and got using the solving polynomial function, then you will not get the mark for this question, right? You're liable to lose the mark for this question, especially in P1 and P2 as well. You should be careful. So it's always good to show that you factorized. All right, so to factorize this, we find 2 numbers that multiply to give you 3. This is one of those easy ones where it's just going to be x and x. you're going to have any other combination there. So you don't have to split the middle term. It's very simple to say, okay, two numbers multiplied to give you the product is positive 3 and the sum is negative 4. Well, they must have the same sign because they're both positive, and the sign must be negative because the product is positive, the same sign, the sum is negative, they both must be negative, and the only way of getting 3 is by 3 times 1. Obviously, it's minus 3 and minus 1. When you multiply minus 3 and minus 1, you get positive 3. When you add them, you get negative 4. So this is the combination we need. So we can say x equals 3 and x equals 1. So we got to now work out, we see E must be the one where x equals 1. And F must be the one where x equals 3, because E comes before F in the diagram. So we can say that the x coordinate for E, we can say the x coordinate, they aren't not asking for the coordinates. So because they're not asking for the coordinates, we're going to just put x coordinate is 1 for E, and for F, the x coordinate is equal to 3. All right. If they said find the coordinates, we would say 1, 2, and 3, 2. Okay, because the y for both of them is 2. But they're not asking for the coordinates, they're asking for the x coordinate of E and the x coordinate of F. So we have found them, and that's the answer to part B of this question. Okay, now for part C, it says shown shaded in figure 3 is the region R1, which is bounded by C, L, and the y-axis. So the region R1 is this darker shaded region between the curve C and the line L and the y-axis. It's what's enclosed between those three lines, those borders. And then the region R2, which is bounded by the curve C and the line segments EF and DF. Okay, EF and DF. All right, so it's this region here, this R2. Okay, so now we've got to use, so given that the area of R1 divided by the area of R2 is equal to K, where K is a constant, use algebraic integration to find the exact value of K, giving your answer as a simplified fraction. Okay, so we want to find the exact value of K, so we've got to basically find the area of R1 and the area of R2 and then divide them, and that will be K. All right, so we know this curve has equation y equals, the curve has equation y equals x squared minus 4x plus 5. This is the line y equals 2. This was the point where, of course, that's y equals 5. This, of course, is when y equals 2, because it's where, so this is y equals 2, not 5. Saying that's equal, that's the line y equals 2. That's the point 2 where this y equals 2 passes through. This is the point where the graph or the curve cuts the y-axis. And we also figured out what the x coordinate of these 2 points were, E and F. Okay, so they were 1 and 3. Okay, so there we have 1 here and 3 here. Those are those two, the x coordinates of E and F. Okay, so now let's concentrate on R1 first. R1. Okay, now R1, if we find the area under the curve between 0 and 1, it's going to give me the whole of this area until the x-axis. Okay, that whole area under the curve. So if I integrate between 0 and 1, the limits, the equation of the curve x squared minus 4x plus 5 with respect to x, it gives me this whole area. And if I take away from that the area of this rectangle, okay, which is 2 times 1, okay, the area of this rectangle, then that's going to give me the area of R1. Okay, that is the area of R1. Okay, so that's pretty simple actually. It's not too much to think about. So you can't just find the area between 0 and 1 of this and leave it, no, because that will tell you the area all the way to the x-axis. We've got to take this away because that's not part of the shaded area. So now we've got to integrate this expression. It's all ready to be integrated. No need to mess about with it or to change anything. So we're going to now add 1 to the power and then divide by the new power. Add 1 to the power, which is a 1 there, so it becomes 2. Divide by the new power, And the constant term just gains an x. Because we're doing definite integral, we don't need to write plus c because we have our limits of 0 and 1. And you've got to take away from that 2 times 1, which is 2. Okay, so that's going to be the area of R1. Okay, so let's see what that gives us. First of all, this becomes 2x squared. So we're going to it's going to be basically, when you put 0 in here, it's all going to become, this whole thing is going to become 0 because x for each term. So we're just going to put 1 in here. So 1 instead of x is going to be 1 cubed over 3 minus, and this is going to be 2 times 1 squared plus 5 times 1 and then minus 2. So you end up with 1 over 3 minus 2 plus 5 minus 2. So that's going to be 5 minus 4, which is 1. So you have 1 plus a third, which is 3 over 3 plus 1 over 3, which is 4 over 3. So we can say the area of R1 is equal to 4 over 3 square units. Okay, so there's the answer to part 2 to R1. That's part of our answer. That's going to be the numerator of the fraction that we're going to use. But now we got to find the area R2, okay, which is this area over here. Now, this one looks a bit easier, to be honest, and I'm going to take a little snapshot of it so we can see what's going on. I'll take a little snapshot, put it down here. Okay, so basically we need to find this shaded, the light shaded area. Okay, now what we know about this, that this is, this point is 1, this is 3. This point is 3, that's 5, that's 2. Now you can see that if I have a triangle here, there's a triangle that looks like this. Okay, that's the triangle. That's 2, that's 5, that's 3. Sorry, that's 1 and that's 2. So it's like this. On the y, this starts at 2. On the x, this starts at 1. Okay, so that's from 1. No, actually, this starts from 0. That's from 0. The triangle starts from 0. 1 is over here. Okay, so this is 0, of course. If we look at the graph, this is 0 to 3. So this distance here is 3. Okay, this distance here is 3. And this distance here also is 3. Okay, so it's like an isosceles triangle, we can say. Although it doesn't look to scale. Anyway, no problem. So the area of the whole triangle is equal to a half times the base times the height, which is going to be 9 over 2. Okay, so the region R2 is equal to the area of the triangle minus the area of A1. If you take away the area of R1, if you take away the area of R1 from this triangle, you're left with R2. So this is R2, the area of R2, equals the area of the triangle, the whole triangle, minus the area of R1. Okay, so the whole triangle, its area is 9 over 2, minus the area of R1, which we just found, is 4 over 3. So we have 9 over 2 minus 4 over 3. We need a bit more space for the rest of the working. So that's going to be over 6. That's 18 over, we have to multiply by 3, sorry, 27 over 6 to multiply by 3. Okay, so 27 over 6 minus, and here we have to multiply by 2. That's going to be 6, and it's going to be 8. So it's 19 over 6 square centimeters. All right, now, we haven't quite finished because they asked us to find the ratio of R1 to R2, which is equal to K. So K is equal to the area of R1, which we found was the area of R1, which is 4 over 3. So we have 4 over 3 divided by the area of R2, which is 19 over 6. Okay, so that therefore K is equal to 4 over 3 times 6 over 19. Okay, so here we can say that 3 goes into 6 2 times. 4 2s are 8, so you have 8 over 19 square centimeters. And that's the answer, okay, to this question number 9. All right, all about integration and area under curves and quadratics and so on. So this is all going to be under the integration chapter. So other questions you might want to find or from this particular paper here will be found in the playlist that will appear in this region over here. Other questions you want to find from integration in P2 can be found in the playlist over here. You can subscribe to the channel by clicking on this link. You can watch a video here which takes you to some it tells you how to use my channel effectively, find what you need quickly. Thank you for watching and see you soon.